This is part 2 of our lesson on reducing expressions. So we just finished a short investigation in which we decided that you cannot reduce when you have addition and subtraction between the terms, and that it has to be in factored form. So we are now going to try a question. It says reduce each of the following expressions, and our first expression is x cubed minus 3x squared plus 4x plus 12 over x to the 4 minus 16. So I can't reduce like the 16 and the 12 because I have subtraction and addition in those expressions. In order to reduce, it has to be factored. So if it's not a multiplication question, right, if we don't have brackets being multiplied by each other, we cannot reduce. So our first job is to take this and factor. So if you would like to pause the video and try doing the factoring on your own, that would be fantastic. If not, you can follow along with me. I'm going to do them over in the margin. So I'm not going to factor them in the fraction. I'm going to take the numerator off to the side, factor it, take the denominator off to the side, factor it, and then put the answers back in over here. So I'm going to start with x to the power of 3 plus 3x squared plus 4x plus 12. I want to factor that. It has 4 terms. So when something has 4 terms, the first thing I would try is common factoring. Do these all have something in common? No. Other than a 1, they don't have anything in common. So then I would try factoring by grouping. So if I were to group these in pairs, would I end up with the same bracket? So sometimes, especially if you're using a pencil, it's not a bad idea just to try. I have a marker, so I have to commit a little bit more. So the first pairing has x squared in common. So x cubed divided by x squared is x. 3x squared divided by x squared is 3. My second pair has a 4 in common. I'm going to do plus 4. 4x divided by 4 is x. 12 divided by 4 is 3. So I ended up with the same bracket here. If I didn't get the same bracket there, that means factoring by grouping is not going to work, and you would need to maybe try to use the factor theorem. But it did work. So this is x plus 3 times x squared plus 4. Now when I'm factoring, you should always check to see if you can go any further. X plus 3 does not factor, but what about x squared plus 4? It has 2 terms, and they are perfect squares. Is that a difference of squares? It's actually a sum of squares, which means we can't factor it. We cannot factor sums of squares. So I'm going to take this expression and put that back in for my numerator. So I know on the top we have x plus 3 times x squared plus 4. Okay, for the denominator, I'm going to take that off to the side. That is x to the 4 minus 16. This has 2 terms being subtracted. X to the 4 has an even exponent, and 16 is a perfect square. So I can factor this as a difference of squares. I would square root x to the power of 4. That really just means dividing its exponent by 2. So that would give me x squared. I'm going to square root 16. That would be 4. One of the brackets is minus, and then the other bracket looks very similar, but has a plus. Can I factor that further? Well, x squared minus 4 has 2 terms. They are being subtracted. They are perfect squares. So this is actually another difference of squares. So I'm going to square root x squared, which is x. I'm going to square root 4, which is 2, minus in the first bracket, and then I repeat the bracket with a plus. If I look at x squared plus 4, that has 2 terms. They are perfect squares, but they are being added. And sum of squares does not factor. Sum of cubes will factor. Sum of squares will not. So this is going to be x minus 2, x plus 2, x squared plus 4. So I'm going to put that back in over here. I have x minus 2 times x plus 2 times x squared plus 4. So the point of this question was to reduce. So I want to look to see, now that it's factored, now that we have multiplication in the numerator and multiplication in the denominator, I can't just cancel numbers, but I can cancel entire brackets if they match. And I see when I look at this that there is an x squared plus 4 on the top, and there is an x squared plus 4 on the bottom. So I can divide the top and bottom by x squared plus 4, and they will cancel out. Right? X squared plus 4 divided by x squared plus 4 is 1. So if you want to be very technical about this, this would be x plus 3 times 1. And then x squared plus 4 divided by x squared plus 4 on the bottom is also 1. So this would be x minus 2 times x plus 2 times 1. Now, we don't normally write the ones because they are very shy and don't like to stand out. So we would normally just say this is x plus 3. And if you think about it, x plus 3 times 1, that's just x plus 3. And then this is x minus 2, x plus 2. So this middle step here is kind of unnecessary. We don't normally write that middle step down. We would just divide it out and then not write the brackets anymore. But it technically is 1, just so we're aware. This divided by that is 1. This divided by that is 1. Okay, so my final answer is this. It would have restrictions. I'm not really worried about that right now, but you could do it restrictions if you wanted to. Okay. All right, I think we're going to do the next example in the next video. I will see you there.